Okay, I think I'm live now. So today we are gonna be solving Codechef cook-off. It happened a week ago, but like we missed solving it. So I'm gonna be solving the first four problems because they have the maximum number of submissions. Okay, so we have four. Okay, cool. So I think let's start. Let's. Can someone let me know if my audio is clear? Thanks for the stream, sir. Okay. Pawan, can you let me know if my audio is clear? Okay, clear. Okay, cool. Perfect. So let's start with the very first problem. So the first problem, it's passing marks. Recently, Chef's college exam was concluded. He was enrolled in three courses and he scored A, B, C in them respectively. To pass the semester, he must score at least A-min, B-min, C-min marks in the respective subjects along with cumulative score of at least T-min. A plus B plus C should be greater than or equal to T-min. Okay. Given seven integers, A min, B min, C min, T min, A, B, C, till whether chef passes the semester or not. Okay. So what the problem essentially means is that we have three subjects, and in the first subject we have A marks, in the second we have B, and in the third we have C. Now, in order to pass this A subject, this A should be greater than or equal to A min, this B should be greater than or equal to B min, and this C should be greater than or equal to C min. And the cumulative sum of all the three subjects A plus B plus C should be greater than or equal to 2 min, T min. So I think the problem is pretty straightforward. All we have to do is write code. Okay, so let's just write the code for this particular problem. Okay, cool. Okay, let's take this here. Okay, so we have t number of test cases. Then for every test case, we have 7 integers. Okay, so we'll have a min, mm, a min, b min, we have c min, and then we have t min, and then we have a, b, and c, which are the marks. Okay, now we'll scan everything. Okay, okay, cool. And now we have a, sorry, a, we have b, and we have c. Okay, just a second. Okay, cool. Now we just need to check if a is greater than or equal to a min, b is greater than or equal to b min. Okay, this has to be a underscore min. And the c is greater than or equal to c min. And let's have a total sum as well. So int t equals to a plus b plus c. And now we need to have and t is greater than or equal to t min. Okay, and if this is yes, then we just have to print yes, sorry, else we print no. I think that's it. Let's try to compile this. Just a second. Okay, t_min was not declared. So yes, this has to be t_min. Okay. So as you can see, everything compiled. So let's try to submit this. Okay. And in the meanwhile, we'll go to the contest page again. Okay, so we have correct answer. Perfect. So let's move on to the next problem. And the next problem is, okay. Okay, so let's move to the other problem. So the other problem says that there are n chocolates and you're given an array of n numbers where the ith number ai is the flavor type of the ith chocolate. Sabrina wants to eat as many different types of chocolates as possible, but she also has to save at least x number of chocolates for her little brother. Now find the maximum possible number of distinct flavor types Sabrina can have. Okay, so we have n chocolates, and this is nothing but an array of n numbers. So let's take the very first example. Let's take this one. So we have 5 chocolates. This is 50, this is 50, this is 50, this is 100, this is 100. Now, Sabrina gives to her brother. Now x is 3 here. That means her brother eats 3 chocolates. So she is actually going to be left with 5 minus 3, that is 2. Now these two have to be maximum number of distinct values. Now, in order to, now as you can see, there are two distinct values. This is 50 and this is 100. Therefore, the answer for this particular case will become 2. And as we can see, the answer is 2. Now, how to solve this? Yes, exactly, Pawan. We need to use sets here. So, what we are actually going to do is we are actually going to insert all these values into set. So, let's say we have a set of int type s. And in this, if we insert all these values, this is actually going to become a set with 50 and 100. Okay. Now we know that the size of this set is 2. Now since the size of this set is 2, we can actually subtract this 2 from the total size of the set. Now we know that the total size of the set was 5 and the size of this set is 2. Therefore from this we get 3 chocolates. That means we have 3 duplicates and the duplicates are 50, 50 and 100. Okay. So now that we know that there are 3 duplicates, we can just give these 3 duplicates to the brother and then we can have the rest of the 2 chocolates for Sabrina. Now let's say this was something y. Then we'd actually have to remove, and we had to give Sabrina's brother x number of chocolates. So now we would first subtract y from this, that these are the duplicate chocolates. So we'll first give all the duplicate chocolates to her brother, and then see what are the total number of chocolates remaining. So n minus this value. Okay. So basically we first took the okay. So basically we first took the duplicate chocolates, we removed them from x, and then whatever x was left, we have to give those values, we have to take the distinct values and give them to n. So this is actually going to be not n, this is actually going to be s dot size. Okay, cool. I hope this is clear. Let's just write the code. So let's move on to the code. Okay, cool. Let's just have it here. Okay. So in the problem, we actually have we first have multiple test cases, right? So we have multiple test cases. Then for every test case, we have intensity and then we have an array n. Now, but we do not even need an array for this. We'll simply have a set. So we have set int s, and then we'll traverse for I equals to 0. Okay. Now we'll have int. So we have n and x actually. So this is n, and this is x. Okay, cool. And temp scene temp, and then we'll insert this temp into this temp into the set. Now we need to find duplicate. We'll first find distinct, the count of distinct. Okay, so this distinct is actually equal to s dot size, and then we'll find the duplicate values. Duplicate equals to n minus. So this is actually going to be n minus distinct. Okay. Now let's see what our final answer is going to be. Now we have answer equals to. So we need to give X chocolates to her brother. So basically this is going to be distinct minus. Then we are actually going to remove some duplicate values from X. Now this is the answer. Now there is one problem. What if this X is actually less than this duplicate? Then this actually will actually have a negative value from this, and this negative and negative will become a positive value and will add into the distinct, and that is not possible. Therefore we'll actually have to take a maximum here with 0, so that we do not fall into that condition. And now, okay, we just print this. Okay, cool. Let's try to run this. I'll remove the board so that you can see. Now when we run this, we actually get 112, which is the right answer. So let's just try and submit this. Okay, submit. So we have C++ 17 here, and then we just paste. And in the meanwhile, I'll open the third problem. Okay. So we have a correct answer for this as well. Now let's come on to the third problem. Now the third problem says that after solving programming problems for years, Chef has become lazy and decided to get a better physique by doing some weightlifting exercises. On any regular day, Chef does n exercises at times a1, a2 till an minutes at all distinct. Okay, perfect. And each exercise provides a tension of b1, b2 till bn units. Okay. In this period between two consecutive exercises, his muscles relax r units of tension per minute. Okay. More formally, Chef's tension is described by a number x. Before any workout, x equals to 0. When it does a workout at time ai, the tension x instantly increases by bi. Okay. Between workouts, the number x decreases by r units of per time, maximize with 0. Okay. Considering the time of exercises and hence tension to be negligible, find the maximum tension he will be feeling in his muscles during the entire period of his workout. Okay. Let's do this one now. So if you see, we are actually given some time frames. So let's say this was A1, then we had A2, then we had A3. And let's say there were multiple times in between. Okay, cool. So at A1 time, so this is also a time, this is also a time. Okay, cool. At A1 time, his muscles are actually gonna get a tension of B1. At A2, the tension will be B2, additional tension will be B2, and at A3, the additional tension is gonna be B3. Now, they say that at every second, his muscles relax for R units. So this is R, this is R, this is R, then we have R here, R here, R here, and R here. Okay. Okay. So we have, yeah, R here. Okay, cool. So if you see, the tension at this point is actually B1 only. Then the tension at this point is B1 minus R. Now the tension at this point, which is this one, is B1 minus 2R. And the tension at this point is B1 minus 3R. Board, okay, board not visible fully. Okay. I hope this is visible now. Okay. Now, at this point now, the tension is going to be B2 plus B1 minus 4R. And we actually going to see if this is positive or not. If this is negative, we actually remove this. Then, similarly, at this particular position, the tension is going to be B2 plus B1 minus 5R. Okay. So, there is one observation that we actually need to do. So, if you see, we have B1 here, B1 minus R here, B1 minus 2R, B1 minus 3R, B1, B2 plus B1 minus 4R, and so on. So if you see, this B1 is actually greater than B1 minus R. This B1 is also greater than B1 minus 2R, and this B1 is also greater than B1 minus 2R. So we actually do not even need to see if this is a maximum value or not, because we know that a bigger value already exists. So we can just simply remove this value, and remove this value. Now let's come on to this value. Now we can never say if this value is going to be greater than B1 or not. Therefore, we'll always have to take this value. Then let's come on to the next value. Now we know that this value is obviously going to be smaller than this value because this has 4R and this has 5R. So we actually do not even need to consider this. And similarly for this position as well. So what comes out of this is that we only need to consider tension at the given time frames only. So we'll have to consider the tension at A1, we'll have to consider the tension at A2, and we'll have to consider the tension at A3. But we actually will have to update the tension at every place. Now, how do we update that? Now, in order to do that, we know that for the very first time, the tension will be B1. Now, for this B2, we actually see that this is 4R. And what this 4R is actually, this is actually A2 minus A1. So, the tension at this B2 is going to be B2 plus B1 minus A2 minus A1 times R. So basically, this is the tension that we got, and this is the tension that is coming from the previous step. So the previous step tension is B1 minus A2 minus A1 times R. And similarly for this also, the tension is going to be B3 plus, then we have B2, but this B2 is actually going to be this updated B2. So let's say this is BUPD, UPD2. So we have BUPD2 minus A3 minus A2 times R. I hope this is clear to everybody, and that's all. Then we only need to find out the maximum values at every time frames, and whatever is the maximum value, we just print that. I hope this is clear to everybody. Okay. So let's just quickly code this up as well. Okay, I'll parse this problem. Okay, cool. We'll just take this and have it here. Sorry. Okay, cool. Okay. So the input is something like we have t, then we have n, then we have r, and then we have an array. Okay. Okay. So we'll have t, then we'll have for every test case we have. Okay. So what do we have? We have n and r. Sorry. Then we have an array of time. So let's make it an array of time only. And then we just scan every possible value. Cn time I. Okay, cool. Then we again have a different array, and let's call it tension. So this is gonna be from I to 0 to n, and then I plus plus, and we'll just scan tension. Okay, cool. So let's have, okay, we do not even need that. Okay, cool. So let's now update this tension values. Now for the very first value, okay, okay, yeah. So for the very first value, we know that we do not have to bring any difference. So we'll actually start this loop from 1 till n. Okay, and then we'll actually add some tension to every position. So tension I is actually gonna become okay. So what do we have to add? So we have to add the tension of the previous value and the difference between time times r. So we'll make tension I minus 1 minus time of I minus time of I minus 1 times r. Okay, so there is one small thing left here that we need to check. We need to check if this value is actually greater than 0 or not. So we'll do this by comma 0, and we'll just take the maximum value. So let me just remove the board. Okay, cool. Okay, so what this is actually going to do is, if whenever this value becomes negative, it will just return a 0. Otherwise we'll always have this value here. So by this we actually we actually updated all the tensions. Now we are just going to sort this tension array. So we have, okay, cool, tension comma tension, and then we just have to take the maximum value, which is actually going to be at the last, and that's, let's just compile this. So we have an error, and the error is actually we missed a semicolon. Okay, so we have the right answers. Now if you actually look at the problem statement, it actually gives that AI is less than equal to 10 to the power 9. Therefore, and when we update this tension, this might actually become greater than 10 to the power 9, and this might come out of the range of int. So what we are going to do is we are going to replace all ints with long. Okay, so I just removed everything. Now we are going to make this as int, and now we'll just submit this problem. Okay, so Kushag says, sir, I'm real. So we have a compilation error. Okay, okay. So this error is actually because now in this maximum, this is actually a long type, and this 0 is an integer. Therefore, and this maximum is not able to find a function for it. So we'll just have this a long as well. Let's submit this now. So we have C++ 17, and let's submit. Okay. So Kushal says that, sir, can I am really struggling with bit manipulation equations. Can you please advise me how can I learn it from where? Okay, so if you know about special classes, you can actually go into an academy special classes section, and then we have many people who have actually taught bit manipulation from the very start. So you can just watch those videos, and I'm sure you'll get these. Also, bit manipulation actually comes with practice. So there are only a couple of things that you need to learn in bit manipulation, but the rest of the part is actually going to come from practice. Okay, so this problem is also done. Let's come on to the fourth problem. Okay, so let's just remove everything. I'll bring the board back in the frame. Okay, cool. So the next problem says that you're given an array A of with n integers. An array score is defined as the bitwise AND of all its elements. Now you need to find the bitwise OR of the scores of all possible non-empty subarrays of A. Okay. Furthermore, there are two queries. Each query consists of two integers x and v. You need to change the value of the element at index x to v. After every query, you again need to find the bitwise OR of the scores of all possible non-empty subarrays. See the example for more clarification. Okay. So the problem says that we actually have so sorry. Okay, so we actually have four values, n values, and these are a1, a2, a3, and so on. Now, for every value, we actually need to have subarrays. So this A1 is actually gonna, let's say this will have m subarrays, and those subarrays are gonna be S1, S2, S3 till Sn. Let's say this A2 is gonna have subarrays named as X1, X2 till XT, and similarly so and so for A3 as well. Now, what we are actually gonna do is, so you need to find the bitwise OR of the scores of all possible non-empty subarrays of A, and before that, an array score is defined as the bitwise AND of all its elements. So if this is a subarray, then we'll find the AND value of all the elements in this S1. Then we'll find the AND of S2, we'll find the AND of S3, and we'll find the AND of Sn. So if you actually look at these subarrays, these subarrays are going to be, one subarray is going to be A1 only, then we'll have A1 comma A2, then we'll have A1 comma A2 comma A3, and so and so. Now if we actually try to find the AND of all these values, sorry, if we actually try to find the AND, then the AND of A1 is actually going to be A1 only, and of this A1 and A2 is, let's say, going to be uh, small a, then this is going to be something b, and so and so. Now we have to find the OR values. Now if we actually look at this a, let's say this a1 was something 1101, the bit manipulation, the decimal representation of the binary representation of a1 was 1101, and let's say for a2 it was 0101, then the AND of this would actually become 0101, which you see is actually smaller than a1. But the set bits are actually something from A1 only. So basically, this A is actually going to have some of the set bits as set which were set in A1, and the same for B and further on. Now, we are given that we actually have to find the OR of all these values. Now, we know that let's say for A1 we had set bits at 1, 5, 1, 3, and 5. Then for A, the set bits are actually going to be either at 1, 3, 4, 5, or a subset of this set only. Then for B, the same thing is going to happen. And now when we find OR, we know that even if we have a set bit for any index, we'll actually have this set in the answer as well. So the OR of all these subsets is actually going to become A1, because we'll eventually in the end have set bits at 1, 3, 5, which were actually set for A1. Then similarly for A2 also, we can say that when we do all of this, when we find all the subarrays, we find the AND of every subarray, and then we have an OR of every subarray. This value is actually the OR of all these subarrays is actually going to become A2, and the same for this A3 as well. So if you look at this problem again now, we have an array, and then we find the subarrays, we find the AND of all the subarrays, and then we find the OR of all these subarrays. But what we see is this A1 is actually going to contribute A1 to the answer. This A2 is going to contribute A2 to the answer, and this A3 is going to contribute A3 to the answer, and so and so. Now let's see what the question says. So furthermore, and so basically the total score is actually going to be another question. You need to find the bitwise OR of the scores of all possible. Okay. The final score is actually going to be OR of all these values. Okay. So furthermore, there are Q queries. Every query consists of two integers x and v. You need to change the value of the index element at index x to v. After each query, you again need to find the bitwise OR of the scores of all possible known empty subarrays. Okay. So if you see, we are actually finding the OR of all this the final values. And now let's say that we were asked to remove this A3 with x3. So we know that from all its subarrays, the value that we'll have to add in the answer is actually going to be x3 only. So what we need now is a1 or a2 or x3. Now we can actually run a loop for every index and find this value. But as you can see, we have 10 to the power 5 number of queries. So for every query, if we run a loop of n, the time complexity is going to become n times q, and therefore we'll get a time limit. So what we need to do here is we actually can do something like this. So since we're actually finding OR only, the final answer is let's say, okay, let's have an example. Let's say we had A1 as 1101, A2 as 0101, and A3 as 1010. Now let's find the OR of all these values. Now the OR of all these values is actually going to become 1, 1, 1, and 1, because we actually had the zeroth index set for from this one and this one. Therefore, the zeroth index for the answer is also going to be set. Then same for this index. This index we had this one here. Therefore, this will be 1 also. And then for this index also we had this one here and here. So the OR is going to be this one. Then for this index also we have 101 and the OR is going to be 1. Now we know that for every index, if we actually get even a single one, that one is going to be counted into the answer. So what we can actually do is we can just write the bit manipulation of all these numbers. So this was 1101, this was 1010, and this was 0101. What we can do is we can actually find the summation at every index. So this becomes 2, this becomes 2, this becomes 1, and this becomes 2. Okay. Now let's say we were given that we remove, what do we remove here? We remove A2 with x2. So we removed A2 with x2, and the bit manipulation of this was 0, 0, 0, and 0. So all we have to do is remove this value. Okay. So we have to remove 1, 0, 1, 0. So when we remove this one, this count actually becomes 1. When we remove this 0, the count doesn't have any difference. Then when we remove this one actually becomes 0. And when we remove this 0, this 2 remains the same. Let's say we inserted 0, 0, 0, 1. So when we insert 0, 0, 0, 1, this for this index the count remains the same. For this index the count remains the same. For this index the count remains the same. And for this index the count becomes 3. Now what does this signify? Now since this is greater than 1, we can say that in the final answer the bit for this index is going to be 1. For this the bit is actually going to be 1. For this, since we have a count of 0, we know that there is no set bit for this particular index in all the values. So this bit is going to be equal to 0, and for this bit we'll have this equal to 1. And therefore the total answer is actually going to become 1101. I hope the solution is clear to everybody. If it is, let's try to code this quickly. Okay. So, okay, let's look at the input first. We have T, then we have N and Q, then we have an array N, and then we have Q number of queries. Okay, cool. So I'll just remove. Okay, we don't really need to do that now. Okay, I'll parse this problem. Okay, let's take. Okay, let's start. So first, so do we have T number of queries? Yes, we have. So we have T test cases. Then for every test case, we have N and Q. So we scan these values as well. Now, okay, now we have an array. So let's say the array was this. Sorry. We scan this array. Okay. And let's have the bits of every an array for the bits of every index. So bit values, and this is gonna be 30. Let's say this is 33, I think. Yeah. So because we have this for 2 to the power 31 minus 1, so this is actually going to be maximum 32 only. Okay, cool. Let's have it for 32. Okay, cool. Okay, now we have to find the bit values for every index. So for that, what we are going to do is for int I equals to 0, we'll again process every value of this array. Okay. So, okay, we have, okay. So what we have to do now is while array I, okay, bit value is equals to array I percentage 2, then we have array I divide by 2. Okay, cool. And we'll have an index equals to 0. This is going to be equal to index, and this is going to be equal to index plus plus. Okay, cool. So this is how, and this will be plus equals, so because we have to find this value for every index. Okay, cool. So now we actually have the summation of every values, this part. Now we have Q queries, so we'll just go for every query. Sorry, this is gonna be 0, this is gonna be Q, and this is gonna be I plus plus. Now we'll have two things, we'll have index and value. We'll scan these two things. Sorry. Okay, now also we'll actually have a value also here, and this is going to be equal to array I, because we are because in this while loop we are actually like removing this array I. So instead of doing this, we can just use value here so that we can maintain the value of array I later on. Okay, so this also becomes value. Now for every query we have index in, so we have index first, right? We are given that input format. Okay, the second line contains, okay, now for we have two space x and v, the position and the new value. Okay, perfect. So what we are essentially going to do is we first have to remove a value. So if we if we are removing a2 with the x2, we first have to remove the count of a2 from every index. So for that we have int temp equals to temp equals to, we have array index minus 1, and now we are just gonna remove this. So we'll copy this particular code, we'll do the same thing here. This will be equal to 10, this again is equal to 10, this again is equal to 10, and now instead of adding we'll actually just subtract this, and this index is also gonna be 10. Okay, cool. And now we have to add this value again. So we'll first reset the value of index 10 to 0 again, and then we'll again copy this code. Okay, so this will also become index 10, this will also become index 10. We have value here. Okay, we have bit value index 10 plus equals to value percentage 2. We have, okay, this will also become index 10. Okay, now we have got the summation of the updated array as well. Now all we need to do is we need to find the decimal the decimal form of this binary value. So for this, now for this, what we are actually going to do is we're going to run a loop. Okay, till 32, and we'll have a value of int power 2 equals to 0. Now what this is essentially going to do is, let's say we have int answer equals to 0 as well. So this answer is actually gonna, sorry, this is going to be 1. Okay, power 2 times, okay, we have bit value greater than bit value for the ith value. So basically what this means is, if the bit value at the ith index is greater than 0, then this particular statement is going to return 1. Otherwise it will return 0. If this is going to return 1, we'll just add that 1 times power 2 into the answer, and then we'll increase power 2, we'll multiply power 2 by 2, and I think that's it. We'll just print answer after this. Let's see if this works. So we have an error, and the error is something like answer plus equals power 2 bit values. This is again, okay, so we have this as bit value. I think now it's okay. Okay, so this has to be index. Where is it? It's at line 36. Index. Okay. Okay, so there is something wrong. Let's just try to debug this. Okay. Okay, let's see what we are doing. The very first issue is that we need to first initialize this with 0, because otherwise, since it is a local array, it is going to have garbage values. So this becomes bit value I equals to 0. Okay, let's see if this works now. Okay, we have 7, 6 and 3. There seems to be some issue with all the answers, like, so we have 7, 6. Okay, so why do we have 3 values only? Okay, and in Q, okay. So we took 3 and 2. No, we should have 3 values only. Okay, so basically what we have to do is we have to print this before as well. Okay, so we'll just copy this, we'll have it here, and we'll also make this answer equals to will. Okay, we'll just cut this, have it here, then answer equals to 0. Okay, we have something wrong. Okay, this power 2 is also going to be initialized here. And we'll just reset this power 2 to 1. So we have an EC, we have 37673, which are equal to the expected output. So let's just try to submit this.